The next part of chapter 8 deals with types of chemical equations. Now remember, a chemical equation represents a chemical reaction. So we're going to look at the different kinds of reactions, and there's 5 basic types. There's a lot more when you get into some other parts like organic and all that, but in general, for you're talking about general chemistry, there's 5 different types, okay? And they're based on the reactants and the products, okay? Not specifically like every time you have oxygen or anything like that. No, it's the way the reactants and the products set up. So again, there's 5 major categories. The first one's called a combination, or I always call it a synthesis. Depends on what book you read, okay? Synthesis means to make something. So a combination, you start with like 2 reactants and they combine to form one product. Decomposition is just the opposite. When something decomposes, it breaks down. So these two are just the opposite of each other. So a decomposition reaction, you would start with one reactant and you would break it down into smaller parts, okay? Then a single and a double, they say displacement. I've also heard them called replacement, either or. But what happens in a single displacement or single replacement is you'll have an element in a compound, and what will happen is that element will replace one element in the compound, so you'll end up with a new element by itself in a new compound. A double displacement is got all kinds of names. Double replacement, double displacement, ionic. Basically, you have 2 compounds and they switch partners. Okay, so your products, you're taking and you're like breaking apart what you started with and recombining them in different order. And then combustion means to burn. Okay, when you guys balance your equations, if you ended up with carbon dioxide and water as your 2 products, that was combustion. One thing you'll notice about those, they're kind of the hardest ones to balance, but they really aren't. There's a rule. Balance the carbon, then balance the hydrogen, save the oxygen for last. If you end up with an odd number of oxygen on one side and even on the other side, double the first carbon compound and then it's easy to balance, okay? We'll talk more about that later. All right, so synthesis reaction or combination reaction. You start with 2 reactants and they combine to do a single product. It also can be you have 3 reactants and you end up with 2 products. In other words, you end up with less parts than you started with. Okay, not the amounts. Remember, the amounts have to be the same. Okay, here's an example. If we take sodium and chlorine and we put them together, we get sodium chloride, salt. Okay, these 2 combined to make something. That's a synthesis reaction. Okay, here's another one. We take calcium oxide and water and we end up with calcium hydroxide. So we start with 2 parts and we end up with 1 product. Okay, the amounts have to be the same because the equations have to be balanced, but I'm talking about like here I have 2 reactants and I only have 1 product. Okay, here's another one with aluminum and bromine. When you put them together, you get aluminum bromide. It's a real violent reaction. Okay, but again, 2 reactants, 1 product. These guys combine to make something, synthesis, okay? All right, decomposition is just the opposite, okay? You're going to start with something and break it down into smaller parts. Remember, to break down means to decompose. So I have a single reactant, I'm going to break it down into its products. And you guys, you can have a compound and break it down into 3 parts. You just end up with more parts than you started with. And again, not the amounts, but just I'm talking about in general. Here I have lead 4 oxide, and I break it down into lead oxide and oxygen. So I start with one thing and I break it down into 2. Okay, here's carbonate, calcium carbonate. When you heat it, it actually breaks down into calcium oxide and carbon dioxide. Okay, so that's another example of decomposition. Start with one thing, break it down into 2. Here's hydrogen peroxide. You can break it down into water and oxygen. Okay, so I start with 1 and break it down into 2. And it doesn't have to be just elements. Okay, notice calcium oxide, carbon dioxide. So it doesn't mean I take peroxide and break it down into hydrogen and oxygen. Here I broke it down into water and oxygen. So it just means you start with some and you end up with more parts than you started with. You decompose something, you break it down. Okay, a single displacement reaction is what happens is you can see I have A, this is an element by itself, and a compound. A is going to push out something, in this case B. Now B is by itself and A combines with C. So you start with 2 reactants and you end with 2 products. So you know it's not synthesis or decomposition because they have different amounts on each side. Here you start with 2 and end with 2. You just got to look for elements by themselves. Okay. All right. So what will happen is the one that's more reactive will replace the other one. Here's an example. Zinc. When you put zinc with hydrochloric acid, you end up with zinc chloride, and this is hydrogen, you guys. Sorry about that. You see I have an element by itself here, and now I have an element by itself here. Okay. So that's an example of a single replacement. Okay. There's actually a way you can tell if they occur, because just because you write out an equation and you balance it doesn't mean it's going to happen. This is called a activity chart. It was actually just done by trial and error. But what'll happen is if I have like nickel trying to replace sodium, it's not going to happen. The ones up here are the most reactive. So you can replace anything below it, but like if I have copper, copper can't replace anything above it. So you can actually use one of these charts to figure out if a reaction is going to occur, especially with single replacement. Okay. So if you see an activities chart, it's just to help you figure out if a reaction really occurs. Okay. Here's another example. Aluminum by itself, copper 2 chloride. Now what's going to happen is aluminum is going to take the place of copper, and copper is going to be by itself. So now I'm going to have aluminum chloride and copper. And I can actually go, okay, here's aluminum and here's copper. So I have aluminum replacing copper. Yes, aluminum can replace anything below it, so this reaction will occur. Okay, this one, if I take silver and I try to replace it, well, silver's way down here and copper's above it, so this reaction won't happen. Okay, copper, silver can't replace copper because copper's above it. That's how an activity series chart. But again, look what's going on here. We have 2, we end with 2. We have an element by itself and an element by itself, so we know it's single replacement. Okay, all right, here's some general types. This is a metal and an acid. Aluminum plus, this is called sulfuric acid. What's going to happen is the aluminum is going to take the place of the hydrogen. The hydrogen is going to be by itself, and the aluminum is going to combine with the sulfate. So again, I look at this, I got an element by itself, oh, that's single replacement. Here I got 2 things and I end with 2, so I know it's not decomposition or it's not synthesis. So here I got sodium. What happens is sodium pushes out hydrogen. So now I got sodium here, hydrogen here. This is a single replacement. Sodium replaces hydrogen, okay? And here's another one, iron and copper sulfate. The iron takes the place of the copper. So now the copper is by itself and the iron's combined with the sulfate. These are all single replacement reactions or single displacement. It depends on, again, what book you read. Okay, there's another example. Okay, in this case, chlorine pushes out iodine. So this would be the anion. Most of these, it's the cation, but here it's the anion replacing. Okay. Okay. Will a reaction take place between nickel and hydrochloric acid? You can write it up. Nickel plus HCl. So what will happen is nickel is supposed to replace hydrogen. Well, oh, now I got to go back. Here, look here. Here's nickel, and here's hydrogen. So yes, nickel will replace hydrogen. Sorry about that. Okay. Okay, so here this reaction will occur. If we look on there and look at tin and aluminum, aluminum is way higher than tin is, so there's not going to be a reaction. Okay. Tin cannot replace aluminum, it's lower on the chart. But this one will happen because nickel is more reactive than hydrogen. Okay. Here's more of the same kind of deal. Okay, let's move on to double displacements. Okay, double is like a single, only now instead of an element in a compound and you end up with a new element in a new compound, now you have 2 compounds and basically they switch partner. So A goes with D and C goes with B. Okay, you always write the cation first, the positive one or the metal first, and then your anion, negative one. That's why they have to go in these, you know, it's not A with C and B with D. You always know that this is the cation and this is the anion. So this cation is going to go with this anion and this cation is going to go with that anion. They're going to switch spots. They switch partners. And again, these are also called ionic, double displacement, double replacement. They got all kinds of names. But really, what happens is they switch partners. Okay. How do I now know? There's an easy way to tell if a chemical reaction occurs, because just because you put stuff together doesn't mean a chemical reaction is going to occur. But with a double replacement reaction, it's really easy to tell. You either got heat or light given off, so there's going to be a change in energy. It's either going to get hot or colder. if you have a precipitate formed. Now, what a precipitate is like you have a clear liquid and all of a sudden it gets cloudy, or you have clumps in it. That's a precipitate, okay? It's a solid formed in a liquid, okay? So if I put two clear liquids together and all of a sudden I got a solid in there or it gets really cloudy, that's a precipitate. That tells me there's a new substance formed. That tells me I have a chemical reaction. And the last one is gas production. If it bubbles or it fizzes, okay? That's how you can tell you got a chemical reaction. Heat or light, given a formation of precipitate, and it bubbles or fizzes, a gas is produced. Okay. Oh, this one I really covered it up. Here I got lead nitrate plus potassium iodide. Okay, so the lead is going to go with the iodine and the potassium is going to go with the nitrate right here. Okay, so you're just switching partners. Here's some more. Here we have an acid and a base. What happens is the hydrogen and the hydroxide combine to form water, and then the sodium and the chlorine form a salt. Okay, so they're switching partners. Here's another one, metal oxide, copper 2 oxide, and an acid. This is nitric acid. What is going to happen is the hydrogen is going to go with the oxygen again to produce water, and then you're going to end up with copper going with the nitrate. So they're going to switch partners. That's a double. So the way to tell the difference between a double and a double, you're going to have two compounds, you're going to end up with two new compounds. In a single, you're going to have an element in a compound, and you're going to end up with a new compound and a different element by itself. Okay? So, here's the formation of precipitate. You can actually tell if they'll form a precipitate. We're not going to spend a lot of time on that. There is an appendix where you can actually look it up. If you take 121, the next one, General Chem, we actually figure that out, but I'm not going to work with that with you guys because it's probably more than we need to do. Okay, but again, you can tell if the way you can tell a chemical reaction occurs. Do they form a precipitate? Is there a change in energy? Is heat or light given off? And do they bubble or fizz? Okay, you can't just say a color change because I can color a piece of paper, or so those ones are iffy. All right, but there's also, here's some examples of double displacement. Again, barium and chlorine, silver and nitrate. Now I'm going to end up with silver chloride and barium nitrate. Okay. This is supposed to be BA, you guys. I didn't do that. This is from the book. Okay, and the last one is called the combustion reaction. Anytime you burn something, you have combustion. Okay, the way it's easy to tell, your products are always carbon dioxide and water. Those are your two products, you got combustion. If it's carbon dioxide, water, and something else, that might be incomplete combustion, might be something else. But carbon dioxide and water, that tells you have combustion. Okay, so here, this is propane. The stuff we use to heat our houses, which we'll be using pretty soon. Maybe some of you have already turned yours on, right? Propane plus oxygen. You have to burn it. You end up with carbon dioxide and water. Those two tell me combustion. Okay. I should have put more on there. Sorry. Okay. Where are we at now? Okay. Here's one. I'm trying to think how many I'm going to do here because I'm almost out of time. So maybe I'll quit right here. Writing equations practice. We'll quit right here and we'll pick this up, and then we'll have one more part to this chapter. All right, so again, 5 different types of reactions we have. Synthesis, we're going to make something. Decomposition, we're going to break something down. Single and double replacement. Single, one element replaces another. Double, you end up with two compounds and you end up with two new compounds, so they switch partners. And combustion. Carbon dioxide and water are your products. Okay, and those are your 5 different types of reactions. Okay, so that's where we'll end today.